All right, everybody. Today we're checking out this new number called e. So the first thing it tells us to do is use our calculator to complete the table for f of n, where f of n is equal to 1 plus 1 over n divided by n for different values of n. Take your answer out to at least 5 decimal places. So I'm going to open up Desmos right here. At the beginning, it's just telling me to take it to the 10th power. So I'm physically doing 1 plus, and then that's going to be 1 divided by 10, and then that's all in parentheses. And then it's getting raised to the 10th power. All right? So that's what it should look like. You get 2.5937. So 2.5937, and then one more decimal place is 4. Right? 1, 2, 3, 4, 5 decimal places. So the next one is telling us to go to 100. So I'm just going to go back in here, go 100, add an extra 0 here. That gave us 2.7048. If we add another 0 in both of these spots, you get 2.71692. Continuing the trend, right? It just wants us to keep adding more zeros. So another 0 in both of these slots would give us 2.7181, basically 5. And then this is to the 5th power, so 10 to the 5th power in both of these cases. Let's see if Desmos can do this. Yeah, 10 to the 5th power is going to give us 2.71827. And then if we go 10th power, you get 2.71828. All right, so why did I have you fill out this table? According to the table, as n goes towards infinity, what number does this function go to? Well, as we get bigger and bigger, it's going to this number 2.718, and then we see it as 28 as 10 to the 10th power right there. So what is this number? Well, it's the number that I told you about at the beginning of the day, right? The number that this approaches becomes as n becomes very large, is known as the number e. The number e is also called the natural base, or the Euler number, or Euler number. It's highly debated whether this is Euler or Euler. After its discovery, Leonard, I'm going to call him Euler. So it says find e on your calculator and write e to 10 digits. So if we pull up Desmos one more time, find e, should just be right here. Yep, so there's e. So it's 2.71828. We want 10 digits, so that's 1, 2, 3, 4, 5, 6. So 8, 1, 8, 7, 8, 9, 10. All right, what kind of number is this, right? What type of number is e? This is called an irrational number. So it's asking us to simplify the following expression involving e. Leave your answer in terms of e. You do not need a calculator for this. You just need to remember the properties of exponents. We can treat e just like a variable or just like a number, right? If this was 2 to the 3rd power multiplied by 2 to the 7th power, we would just go 2 to the 3 plus 7. Same thing works with e, right? This is e to the 3rd plus 7, which gives us e to the 10th power. Whenever we multiply like bases, we add the exponents. Same thing is going to happen when we divide, right? Instead, division is subtraction. So we go 15 divided by 3. That gives us 5e to the 8 minus 2. So this is 5e to the 6th power. We take a power to a power. We have to distribute. In this case, right, negative 5x is one singular thing. So we distribute straight to there. And we have to also distribute to the 3. So we distribute to each base individually. So this is 3 to the 4th power, e to the negative 20x, right? 3 to the fourth, it's like 81 times 3, it's a big number. We're just going to say 3 to the fourth, that's fine. E to the negative 20, x moves to the bottom, so it just becomes e to the 20x down there. And we're good, just like that. So it says use your calculator to evaluate the following expressions, e squared and e to the negative 0.63. So let's do that. So we'll take e and we'll square it. That gives us 7.389, which that's a pretty popular number as well, e squared. But I'm only concerned with having us memorize e right now. So we have to memorize that 2.7828. So a lot of people just take 2.718, and you're usually pretty good. Here we're going e to the negative 0.63, so that's 0.5326. All right, so let's take a look at graphing e. So it says graph the function. Use the graphing methods we have been using, then state the domain and range. You should be able to write this without a graphing calculator. Remember, we have graphed exponents last week. This is no different. Your b value is e, or 2.71, or actually that should be 2.72 technically. We need to think of e as 2.718. That's what we need to think of e as. And that will be our approximate point. In this case, I'm only going to make you use two numbers. Only use two numbers. So when you're building the base, you go x, y, use to the 0 power, which is the easiest one ever if we're raising exponents, right? E to the 0 is just 1. And use the first power, so e to the first power, 2.718. And then you just graph these 2 points. So 0, 1, and then 1, 2.718 is like almost 2 3/4, right? You have to make sure you graph the horizontal asymptotes here. And it's important because we're not graphing any points to the left of this, so we need to make sure we're not crossing the line that is the asymptote. So there's our graph, right? No shifting, no multiplying by things, just straight up e to the x. All right, let's take a look at this next one. So we have 3e to the x plus 2. So here we go x and y, right? Of just e would be 0 and 1. And then we'd have 1 and then 2.718, right? So then we take this, we take both of those points. It's 3 is the a value, so we multiply it by 3. This is going to give us 3. 3 times 2.7, right, that's going to be 6. And then 3 times 7 is 21, so that's 2.1. So 6 plus 2.1 is about 8.1, right, approximately 8.1 when we multiply it by 3. So then we have points at 0, 3, 1, 2, 3, and 1, 8.1, 3, 4, 5, 6, 7, 8. So we're right here. And then that is telling us to shift everything to the left 2. So we're going left 2, and here we are. We need to draw in our horizontal asymptote so we don't cross it. The horizontal asymptote does not change, so it's still y equals 0 because there's no vertical shift. And then we're going to graph this, right? So it's going to look something like this. And again, 2 points, that's all you need. Continuing on, letter C right here. All right, now we have xy, so 0, 1, 1, 2.718. And it's telling us to multiply all of these by negative 2. So multiplied by negative 2 gives us negative 2. Multiplied by negative 2, that's going to give us what? Negative 4, negative 5.4, approximately. And then it's telling us to shift everything up 2 after that. So let's graph those points. So we have 0, negative 2. And then we have 1, negative 5.4. 1, 2, 3, 4, 5.4, like right here. And then it's telling us to shift all of those points up 2. So let's draw our horizontal asymptote, plus 2, just like if it was an exponent. And then we're going to take our points, and those also need to move up 2. So 1, 2 puts us right here. And then we can graph that, right? In this instance, it should be going down into negative infinity. Awesome. So last one, right? X and Y, 0 and 1 would give us 1 and 2.718. And then it's telling us to shift right 3 up 1. So our horizontal asymptote, I guess let's draw the points first, right? So we have 0, 1, sorry. Something caught in my throat this morning. 0, 1 and 1 and 2.718, which puts us right here. And then it physically says, okay, shift those points up 1 and to the right 3. Up 1, 1, 2, 3. We also know that the horizontal asymptote shifts up 1. So then we're right here. There it is. All right. Let's talk about all of these domains and ranges. Remember, domain is always all real numbers. So when you come through any of these, you can say all real numbers. The range for this first one, it's 0 is the lowest, but it's not included. And then it's going up forever, so towards positive infinity. For letter B here, our domain, same thing, all real numbers. The range, in this case, right, is still 0. There was no vertical shift, so we're still going 0 to positive infinity. Letter C, domain, all real numbers. Range this time, it's going down forever, so we say it's coming from negative infinity, and then it's going up towards, we had to shift up 2, so positive 2. And then lastly, domain all real numbers. Range in this case is going from 1 to positive infinity. All right? And that's how you graph E. I just need 2 points for E. It's not like exponents. Exponents, the expectation is 3. E is just 2 because I don't expect us to memorize E to the negative 1. All right? Coming down here, in 6.2, we learned that the amount A in an account earning interest compounded n times per year T is given by this equation, right? We also learned that as n goes to positive infinity, this approaches the letter E, right? So basically, as we're taking this equation to positive infinity, we're getting out the number E, right? So there is a formula for compounding interest that uses this value. It says find the formula and define all the parts. Well, I'm teaching this one, so I'll give it to you. In this case, it says A is still the final amount here. A is equal to P times E raised to the R T. We call this equation PERT. It's the PERT equation. And it's for compounding continuously. So we've had compounded monthly, we've had compounded quarterly, we've had I think that's it, compounded monthly and quarterly, really. This is continuously. So there's a whole nother word for this one. P is our initial amount. E we know as 2.718. R is the rate that they're getting. And T is the time. In years, usually in years. So it says you deposit $1,000 into an account that pays 8% annual interest compounded continuously. What is the balance after 2 years? So we just use our equation. A equals 1,000 times E raised to the rate, which is 0.08, multiplied by 2. So 2 years. So let's pull out Desmos, see what that gives us. We have 1,000 E raised to the R times T, which is 2. So that's telling us after 2 years, this is going to have $2,166.57. Okay, next one. It says you deposit $5,000 into an account that pays 7.5 interest compounded continuously. What is the balance after 5 years? So again, same exact equation, right? 5,000. E raised to the R, which is 0.075, times T, which is 5 years. So then we change up this equation. 5,000 e raised to the r, oh my gosh, which is 0.075 times t, which is 5. Whoops, that's not it. Times t, which, oh my gosh, why is it not doing that? Here, I'll just put parentheses. Which gives us 7,274.96 if we round up correctly. That also makes me wonder if that last one did that. Let's go back and double check that last one. So last one was 1,000 e raised to the r, which is 0.08, times t, which is 2. Oh yeah, it did do that. Sorry. Okay, that's 1173.51. 1173.51. There we go. All right, so next one. You deposit $10,000 into an account that pays 5.25% annual interest. What is the account balance after 5 years if it's compounded yearly? So yearly is the normal C plus 1. So we're going 10,000 multiplied by 1 plus our interest rate, 0.0525, raised to 5 years. So let's get that number. It's 10,000 multiplied by 1.05225. And then that's raised to 10 years, which gives us out a final balance of $16,680.96. If we go compounded monthly, right, we need to switch up this equation. So that's 1 plus, and then r, which is 0.0525 divided by monthly, which would be 12 times in 1 year. And then that's raised to the 12 times 10. Right, so this equation looks like this: 10,000, 1 plus 0.0525 over 12, because that's the number of times compounded in a year, and then times 12, that number goes to the top as well, multiplied by t, which is still 5 years. That gave us out $16,885.24. And lastly, we have our PERT equation, so 2,000 e to the r, 0.0525, times t, which is 5. Let's see what that gives us. So 10,000 times e raised to the r, which is 0.0525, multiplied by t, which is 5. Which that gives us, why are my numbers off? 13,001.76. Okay, my numbers are off for the first two. Why are they off? Did I just do, let's do this again. 10,000, right? And then we have 1 plus 0.0525 divided by 12, and then raised to the 12 times 5. There it is, 12,994. Why were my numbers so off? I'm sorry, guys. 12,994.32. Hopefully you were doing those in your graphing calculator and you're like, Mr. Heinlein, you're so wrong. All right, 10,000, 1, 2, 3, multiplied by 1. I'm just going to go plus 0.0525. I must have been doing 52%. I don't even know. Raised to the 5th power. There it is. That's better. 12,915.48. All right, those are better, right? Your compounded continuously should be your highest value because continuously means it's constantly getting compounded. All right, monthly is 12 times, yearly is just once every year. All right, If you have any questions about plugging those into your calculator, because apparently I was missing how to do that the first time I went through, please let me know. I'd be happy to help. And as always, if you have questions, just message me on Canvas. Have a great day.